Dear friends and colleagues, welcome to the Mangano Digital Academy. I'm very excited to kick off today Essentials of Digital Dentistry. Digital technologies are revolutionizing the world of dentistry, but there are still confusions regarding the basic concepts underlying hardware, software and workflows. The purpose of Essentials of Digital Dentistry is to definitely clarify some doubts which many colleagues still have. Only from a solid base it is possible to unlock the potential of the digital dental revolution. Before to start, I would like to thank Kerstin Dental and SMOP for sponsoring this initiative that consists in 40 videos covering the details of the whole digital dentistry and the whole workflows in digital dentistry. These videos are organized according to the Scan Plan Make Done protocol, and the series will be available across the Mangano Digital Academy website, social media and the Kerstin Dental social channels. With that, let's get started with the first topic. The first topic we will talk about is the workflow in digital dentistry, because it's very important to define the different phases of the work. So our workflow is based essentially on 4 phases. There's the scan phases with the data acquisition, 3D data acquisition from our patient. Then we have to plan using our software. So we have a data elaboration. And after planning, we need to make our devices for clinical application. After that, we need to apply these devices clinically. In this first lecture, I will talk about the cone beam computed tomography. So we will focus on the scan phase. And the question is, what is the radiation dose of a cone beam computed tomography? The cone beam computed tomography appeared in the late 90s as a new technology using a cone-shaped beam and a reciprocating detector which rotates around the patient 360 degrees in order to acquire projected data in a single rotation. And after that, it immediately invaded dentistry because it made the perception of 3D easily acceptable to all dentists. Now, cone beam computed tomography are in all dental offices around the world because they are really game changer. And the radiation dose is a very important topic when we talk about cone beam computed tomography. In the early 2000s, when I was in University of Varese with Professor Aldo Macchi, we started to consider these concepts. And basically, we need to consider, when we talk about radiation dose, we need to consider 3 different things: the absorbed dose, the equivalent dose, but most of all, the effective dose. The effective dose, measured in milli or microsievert, is the weighted sum of the equivalent doses to the various organs. And there's a corrective factor that takes into account the sensitivity of the various organs. And generally, usually, we use this parameter to understand the radiation dose coming from a CBCT scan. And as I told you, our first experiences are dated early 2000s. And we made some dosimetric evaluation and an evaluation of the dose absorbed by the organs and the effective dose. And we wanted to compare the conventional medical CT with the cone beam computed tomography. And this work was made by Professor Sabina Strocchi and by Professor Aldo Macchi and all the team at the University of Varese. And we used Anderson Raldo Phantom. We placed some dosimeter. And we exposed this phantom to different scans with the different machine in order to evaluate the effective doses. And we wanted to compare basically these 3 machines: a conventional medical CT, the Toshiba 64 multi-slice, then a CBCT, a cone beam computed tomography, the one that was available at that time, the ECAT, and then a digital orthopantomograph, the Sirona Orthophos. We wanted to compare the different doses, and particularly the effective doses given to different organs by these machines. And immediately we have seen that, considering the absorbed dose in milligray, we found that, of course, there was no competition, because the conventional medical CT gives much more radiation than all the other two machines, obviously. But if we consider only the cone-beam computed tomography and the panoramic radiograph, the digital panoramic radiograph, in this case we see that there's competition, I would say, and particularly for some organs the 3D CBCT was capable at that time to give less radiation. So these were the first evaluation, the first tables, considering the different organs with the absorbed doses. And we found that the CT was playing in another league, but the cone-beam computed tomography, with the application of 20 seconds, in some cases it was very similar to the panoramic radiograph. And when we shifted to the effective doses, that is what we usually evaluate in millisievert, we found that according to the different application, we could have different doses, and the orthophos, the panoramic radiograph, gave more or less the same effective doses given by the cone-beam computed tomography in the 10-second application. Obviously, the Toshiba, with the two different protocols, with the standard protocol, but also with the 200 milliampere protocol, was much higher in terms of effective doses. And the results from this first evaluation was that, of course, the medical CT delivers the highest effective doses with the two different protocols, and the doses delivered by cone-beam computed tomography were, of course, much lower than those of computerized tomography. For the conclusions were very, easy. Cone-beam computed tomography is capable to provide high-quality images that are perfect for the dentomaxillofacial purposes, and considering this fact, and considering that the doses, the radiation doses, are much lower than those given by a medical CT, it's of course the ideal tool for dental and maxillofacial purposes in order to investigate the hard tissues of the oral cavity and also the maxillofacial district. So it no longer makes sense in this case to use conventional medical CT in the dentomaxillofacial areas, because the radiation doses given can be even 22 times higher for a medical CT when compared to a cone-beam computed tomography. And our evaluation and our numbers were confirmed a few years later in the book by Schutizer and colleagues, because they found, basically with another machine in this case, with another machine for the medical CT, they found that more or less the numbers were the same, and they confirmed our evaluation. And obviously we have a significant dose reduction with CBCT when compared to the medical CT, a dose reduction that, according to Schulze and colleagues in this paper published in Dentomaxillofacial Radiology in 2004, is up to 98%. So we are talking about something that is definitely not possible to discuss, because it's something obvious. And other papers with different researchers involved, Ludlow and colleagues, they confirmed that we have, of course, a range and some variability across the dose given by the different machine and using different applications by the different cone-beam computed tomographies. But anyway, the effective doses were absolutely lower than those given by a medical CT. And we have a dose reduction that is absolutely out of discussion, and we have a variability between the different machines and between the different protocols among the different cone-beam computed tomographies, because along the years a lot of machines appeared in the market with different characteristics, different features. And we can summarize a little bit the results provided by these different studies and these different literature reviews, and we see that we have doses in microsievert that are comprised with CBCT around 36.9, 50.3 microsievert compared to, for example, the digital panoramic and the cephalometry and the endoral status. So we have to consider that anyway the dose is higher than with 2D conventional radiography, but much lower than the dose given by SCT. And this literature review summarized a little bit all this aspect, and the authors in this case shed the light on the fact that obviously there are big variation among the different machines, and there are different protocols available with the different machine, and of course it's not surprising that we can have big ranges for the doses given by the different combined computed tomography depending on the application, as we can see here from these graphs, and also depending by the field of view, because the field of view is very important. The area that we are going to scan with our combined computed tomography is also very important. And this systematic review more or less confirmed the evidence emerging from the previous studies. And Ludlow, with another literature review, found that there are also significant differences between the different combined computed tomography that are available in the market. And in this case, the author considered that the acquisition protocol is absolutely very important. And I think it's one of the most important things we should consider now, because now, after 20 years, the combined computed tomography is is spreading in all the world. We can find CBCT in almost all dental offices, and so it's very important to apply the proper protocol in order to reduce the dose to the patient and to follow the recommendation given by the different institutions in terms of reduction of the absorbed doses. Particularly interesting is this trend for searching low dose protocols in order to reduce the number of, for example, projections, and it's possible today with the modern machine to dramatically reduce the doses given by the patient, following the standards given by the ALARA and ALADA principles. So it is possible, for example, for diagnostic purposes, it does not affect the diagnostic capability when we use some low-dose protocols, and also low-dose protocols are currently under investigation for other, applications, such as, for example, guided implant surgery. This is a recent report from 2018 from the group of Professor Ludlow. And as we can see, with the most recent machine in the market, in this case CS9600, we can see that we can have a further dose reduction when considering the different, for example, application protocol. And we have also important low dose protocols that can help a lot in order to, to allow the clinician to make the proper diagnosis and treatment planning, but at the same time reduce a lot the radiation doses. As we can see from this last table, this is the effective doses to the organ in microsievert, and as we can see, and if we compare these values with the first values that I showed you at the beginning of this presentation, we see the evolution, the incredible evolution that we had along these 20 years, because the machine became much more, easier to use, and definitely they can provide much really high quality images, much more than before, and at the same time it is possible to dramatically reduce the dose given to the patient with a lot of benefits biologically. So the evolution and the advancement have been amazing. If you consider that with a 5x5 program we can have a low dose with 7 microsievert, and it's really impressive in this application, and from this table we can see that the evolution was amazing. So thank you very much for your kind attention, and please, if you have some question or some doubts or criticisms, don't forget to write me, because I'm here to answer to all the questions. Thank you.